example 1, we've got a graph that shows the height y, so my height is my y-axis, of an object as a function of time x. So these numbers on my x-axis represent time. First thing we want to do is identify the function as linear or nonlinear, then we're going to estimate and interpret the intercepts. So, linear or nonlinear. If it's linear, it would be a straight line. And obviously this is not a straight line, it is curved, so I can say it is nonlinear. Now that I know it's nonlinear, I want to estimate and interpret the intercepts. So the first intercept I want to find is the y-intercept. Remember, the y-intercept is where it crosses the y-axis. And the y-intercept is about 0, I'm going to say 17 maybe. It's at 0.17. So that's my intercept. But now I need to interpret it. I need to say what it means. So I can say I have 0 for time. So at 0 seconds, the object was at 17 feet, because my y value is my height. Now another way to think of this is the object was launched from a height of 17 feet. That would also work. This is the most basic way to say it though. At 0 seconds the object was at 17 feet. And then the x-intercept, where it crosses the x-axis, and I'm going to say this is 1, 2, 3, 4, 5, 6, 7, about 7.5, let's say. So we'll go 7.5, comma 0. Remember, your y is always 0 for an x-intercept. And what does this mean? Well, at 7.5 seconds, the height was 0. Or we could say the object was in the air for 7.5 seconds. Because it went up in the air and then came down at 7.5 seconds. So it's in the air for 7.5 seconds. And that's all we had to do. We had to estimate these intercepts and then say what they meant. So let's look at example 2 very quickly. The first thing we want to talk about is what line symmetry is. So when a graph has line symmetry or possesses, so when a graph possesses or has line symmetry in the y-axis or some other vertical line, if each half of the graph on either side of the line matches exactly. And you can see right here I've got my line of symmetry, because if I drew in this line, I would see the exact same thing on the left side of the line as I would on the right side. So it has line symmetry. And describe and interpret it. So here is the symmetry. And what does it mean? Well, obviously it went up to 60 and then back down to 0. So the object, if I was going to say what that means, symmetry basically tells me it went up for the same amount of time that it went down. So I'm going to say the object went up for the same amount of time as it fell. So basically what the symmetry can help us identify is if the exact same thing is happening on either side of it. So here we know what that means. We can also say the object was at its highest point at about 3.5 seconds, something like that. Okay, symmetry can help us in those ways.